All right. Good afternoon, everybody. So, let's start with my first naive take. Fairly young guy here. So, I'm neither a data engineer nor a data scientist, but I just wanted to draw some parallels here between the two and kind of define them here so we're all working on the same definition. Oops. So, data engineers, typically when you say data engineering, you think ETL, which is extract, transform, and load. And then data engineers typically work with databases. They focus on data quality, and they work on building pipelines for the data scientists, and an emphasis on getting the data into formats that they can use. And then data scientists, on the other hand, use statistics, create models, machine learning in parentheses. They work on creating reports from those. It's not necessarily that people are one or the other. They can be both at the same time. It's more so putting the work that you're doing into separate buckets. So my second naive take here, maybe a little controversial. Bioinformatics and computational biology. Bioinformatics, you focus on running tools. We work with files, focus on data quality. Focus is on building pipelines that transform the data into formats that then computational biologists can use. So computational biologists focus on the stats. They create models, focus on creating reports, create algorithms. Again, you're neither one or the other. You can be both. It's great. But just kind of wanted to draw the parallels between the two before we dove into all of this and where I kind of see the fields myself. So, big data. It's dead. The modern data struggle here that we've kind of created is very few people are making these ginormous queries. They're not, that's what they found at BigQuery, was they had tons and tons of, I guess I'll keep going. So they kept making a ton of queries, and they found what actually people were doing was they were actually just using BigQuery because it was so easy to use, not because they needed to query petabytes of data and do these massive queries. Most of it's actually done on recent data. Think about when you're running a sequencing facility, you're mostly processing the data that has just come off the sequencer, not working through all of these like back samples in that sense and reprocessing those. And a lot of people save it for a really long time. Like, what if we need it in the future though? What if we need to reprocess these? That's fine, we put it in Glacier and move on with our lives. And then, so now all these files are sitting in object stores, like S3, for example, as well. And as bioinformaticians, we love files. So, let's get into DuckDB. Just in case none of you have heard of what DuckDB is, it is a open source, MIT licensed, in-process SQL OLAP database management system. That's a lot of jargon. Essentially, you can think of it like SQLite for analytics is what a lot of people like to call it. So the idea is that you can basically run these SQL queries directly on files, CSVs, TSVs, JSON, all that good stuff. You don't need to have a whole database running and headaches of client and thinking about all of that stuff is kind of the idea, which is kind of where we get out of the scope of bioinformatics and where we're kind of like, we'd rather have files. It's also really fast. A lot of cutting edge database research is being done on it. L1 cache optimized, if that means anything to you, basically it stays around the CPU is kind of the idea. Go look up some talks on it, it's really interesting. And then also the query execution engine is optimized to do all these things in a very fast way, compared to if you tried to use SQLite to do some of these queries. The other thing that they claim, it runs anywhere, as all good tools do, on the cloud, on HPC, on your laptop, on that old Mac in your lab that won't die. So, just to kind of give you an overview of the picture, that came out really faded. Up there on the top left is SQLite, and then you have DuckDB next to it, just to give you an idea of those are both in-process databases versus the client-server model, which would be like Postgres, or now ClickHouse if you're up with the times on like doing analytics on those. So, just a little bit of DuckDB there. It's coming out really tiny. Hope y'all can see in the back. So, you can see that we're actually querying directly from S3 here, and we're querying Parquet files. We'll talk about that in a little bit. You can see some wildcards going on in there, various globbing and whatnot, and so we can just run these queries directly on those files. Can also work with local files as well, which is important. And then you can also query from data frames, and we'll talk about that in a moment. And then you can also just hit random HTTP URLs. Kind of reminds me of something. So you can also use it with a lot of popular tools, such as pandas, just kind of baked in there on this. And the main point down there is you can see the my data frame is where the querying is coming from. I wonder. Yeah. So another thing that might be of interest to some people is it's also PySpark compatible with an API. The main thing that it does is you just swap between, so this line here is just getting the environment variables, and then these are just pulling in the DuckDB version of the function, and then this is the Spark session from that, if that makes sense. So it's just pulling one or the other, and then the results of it is DuckDB spins up a lot faster locally. Obviously, Spark you can scale a lot more, but it's great for these small workflows that people may have just doing quick little queries, and you don't need to run a whole Spark cluster. Okay, and another recent addition is they've, a group has developed a plugin for DuckDB that then allows you to pull in biological data formats. That's really interesting to us here. So, such as GFF here is what this example is showing. So we're just querying a GFF file, and from those, pulling in all the gene annotations, and then this would just print all the gene annotations here on those. So let's talk about Nextflow and DuckDB and some examples on that. We had some recent Slack discussions on kind of, we wanted to make an NF core module for it, but we didn't know what the best way to like kind of bundle this up. So I kind of went down the rabbit hole, so bear with me here. So what we're looking at here, this was a recent discussion that came up in the Nextflow Slack as well, was using, they were basically talking about building a Parquet plugin for Nextflow to start reading it, and they realized they could just use the SQLDB plugin to read the Parquet file. And so what this does here is we're selecting from the Parquet file, and then if you run that in Nextflow, it will just spit out all of those from the Parquet file, which starts to become really powerful, is then you can start to query all of these outside, and while Nextflow has great built-in functions for those, you can start to utilize SQL queries to ask questions of your data. So another thing that I've always been thinking about as well is looking at data engineering and looking at popular tools like DBT. I love to keep up with software tools for whatever reason. And so on the left here, that would just be a DBT syntax, and you can see the ref, and they're staging customers in. There's a whole lot of stuff going on the back end, to be fair, and then also on Nextflow, there's a whole lot of stuff going on the back end. But basically, we can kind of go one-to-one on those two and use the Nextflow syntax there. So that's just the DBT syntax, and then now the Nextflow syntax that would be the equivalent is down there with the staging customer file in, and you can just have Nextflow stage it for you, which I think is pretty cool and equivalent. It's very, very popular in the SQL space. So let's talk about staging files for a minute. This is kind of an anti-pattern that I don't love, but it's part of it. So we all know you stage a file in Nextflow, pull it in, with this. So what we're doing here, pulling in a CSV, and then we're reading from that CSV with DuckDB. You can just use it as a CLI command, just like this on that, so it starts to become really powerful in Nextflow scripts. And then we can also use stuff like greater than, and then we can just say, use this variable and pull it in with DuckDB and start to do some logic based on that. So DuckDB, however, also already has its own plugin that does something very similar to the Nextflow function, which is the HTTPF plugin. And all the way down there at the bottom, if you can see it, we have the link, which is just the S3 link on my iTest here. And then you can see the read CSV down there. And so that's letting DuckDB actually stage the file itself and pull that in. Not the best practice in Nextflow, but it becomes really powerful when you start using formats like Parquet, because you can just pull the columns that you want from the Parquet file rather than staging the entire file with Nextflow. I need to do some comparison of that with Fusion and pulling Parquet natively with DuckDB and see which one's faster as well. Okay, so another little rabbit hole here was I started to think, well, okay, could I use a template file? Because these files start to get really long with the queries. And so you just pass it a bash file, and then you can start to use all this templating and whatnot. These are actually DBT queries that I just kind of swapped in with Nextflow on those, and you can just start to pass all these files in rather than having to have separate tables. You can just write to files like you're kind of expecting to in bioinformatics. And then next, I went down another rabbit hole of like, what if we start to pass the query directly to DuckDB? So you kind of pass it in as a variable to the process, and then from that query, then we can then run it. And you're kind of wondering, okay, why would we want to do that? And so my thought behind this was all of these new AI tools that have come out that write SQL on all this data. You can have a process that's running that, pull that in, and then next you can run your tables on that and start to ask questions of it and generate these things. Okay. So you can also use an SQL file as well as a native built-in DuckDB thing. So there's the file up there, and we're passing this in actually with Nextflow itself in the project directory. I can get to use the bin directory. I don't think DuckDB is smart enough to do that inside of it. And so then we're passing this file query down there, and then we're going to pass next the CSV and just cat it into DuckDB, and then run that query on it. As you can see, then we're passing our CSV, which is the next Netflix top 10, and then going from there. So the problem with this that I found was that DuckDB doesn't really like the Nextflow variable replacements sitting in its SQL files. It started to throw errors with that. So I didn't really love that. But I came up with a little idea that I haven't fleshed out entirely. But there's the template function in Nextflow. What if we had, so like first, I really wanted a shebang instead with DuckDB, and then you can just run an SQL file just natively from that. And I think that'd be a really cool feature. But that's more on the DuckDB side, just that. But I wanted to have a like SQL template from that, and then from that, basically we can start to have a little line here, which is just the SQL, and then that will pull in the CSV. And what that turns into is that down there, which is DuckDB-C. And basically just wraps that. So what's the catch with DuckDB? What do we kind of need from this? Everyone will tell you it's great if it runs on one machine. We have really big machines now. That's fantastic. If only there was a tool for orchestrating single machine processes at scale. So I kind of like to think of it as the internet question of, would you rather fight a horse-sized duck or 100 duck-sized horses? And so what that ends up looking like in Nextflow is then you can start to use split, and like you could split up a giant CSV, a giant file that you had, and then start to run separate DuckDB processes on this so you don't need to rent out a huge machine. Interested to hear if anybody has any actual use cases for that, but just kind of a thought. So found some anti-patterns talking to Abhinav about this. Essentially, if you're running it with the Nextflow SQLDB, that plugin is designed to be a client, such as like Athena, BigQuery, Postgres, and act as that. So the problem is it could put pressure on the head node if you're running your DB on the head node and crash your job. So don't really recommend that, although that is totally possible with it. But there's a new service as well called MotherDuck that will be out that could also alleviate this, and you can just push your queries out to the cloud and creates that client-server model. So some ideas for use cases in NF-Core. We have the new NF-Core CO2 footprint plugin coming out. We can query that, and I can answer for all my GitHub action sins as well. And then also, we could also start to query on build for what's the most used module in all of the pipelines on that. Okay, so another aside, if I've not thrown enough jargon y'all's way. So there's the medallion architecture, which is another modern data stack thing that Databricks coined. So you have your bronze data, which is your raw data integration, the silver, which is then starting to be filtered, cleaned up, processed a little, and then you have the gold, which starts to be like business aggregated, read counts, et cetera, in the bioinformatics world. And then I was kind of looking at this and learning about it, and I started to look at it, and I was like, well, I mean, multi-QC kind of already gets you to silver, doesn't it? And I was telling this to Graham, and he said, I just thought multi-QC was a pretty HTML report. Edmund Miller. A little office quote there for everyone, or reference. So multi-QC also cleans your data, in case you didn't know. In the multi-QC data and the multi-QC data JSON, it has all of these samples and all kinds of data in there. Everything that you see in the report is also in the data JSON. And coming up soon, it will also be in Parquet by default with the Pydantic rewrite coming up. So we'll be able to query all these things, use Iceberg, all the fast modern data stuff, just kind of out of the box. So we can start querying that then. So I just threw together a little query here from the multi-QC outputs in the AWS megatests for NF Core. This one's just pulling in some SAM stats from that and just from RNA-seq. So just pulling in the samples and the various results of how many reads were mapped and paired, just to kind of get you thinking about that. So let's talk about MegaQC. It's essentially multi-QC for your multi-QC. It's another one of Phil's projects. I love the idea. I really wanted to run it. Oh, that is really faded. Basically, that's the output of all of it, and then you can see the various plots coming up and all of the different samples from that, and it aggregates all of your multi-QC reports into one giant report. It's kind of the idea that then you can query and dashboard on that. However, I wasn't able to get it up and running. I don't know what the state of it is exactly. So we can then start to kind of think in aggregates on these. From that, just using DuckDB rather than needing to build out all of multi-QC and start answering these questions right now from our data lakehouses that we've built inadvertently. So we have the read CSV up there going and pulling in the file names on all these. This one's just pulling from Seric. And then that just pulls in all the samples and pulls in the reads mapped and paired as well. Just to kind of get the idea, the main takeaway here is the wildcard in there that allows you to query all of the results files in the AWS S3 bucket. So with that, we've already built the data lakehouses that we need unknowingly. We've skipped over the whole part where we pay a bunch of money to have our data in databases. And with DuckDB and Nextflow in combination, we can capitalize on them. Thank you.
Great, we've got at least 3 questions here. One was around the writing this as a plugin. Was there any kind of need to write as a plugin? Did you think about that, or was it just standard enough to use it as a command line tool?
Exactly, it's standard enough to use as a command line tool. I did not write a plugin. There was a SQL DB plugin that already had access to DuckDB ahead of time.
And then kind of more related to the application here, could you elaborate on how DuckDB and Nextflow can be integrated to optimize, simplify data management and workflow automation? Additionally, how do these tools address the unique challenges of handling genomic data sets?
To answer the first part first. Pulling in all the various samples, you could generate a sample sheet on the fly is one thing that we've talked about. From those, pulling in like, okay, we want the top 10 data sets on this with the highest read quality or whatever, and generating those on the fly, building a dashboard from that, or kicking off Nextflow runs from that. Remind me what the second part was.
Yeah, me too. It was around, like, additionally, how do these tools address those challenges? Yeah.
Right, so, and addressing these tools, it basically allows you could throw this in a Nextflow process, generate it on the fly as your workflow is going, or ahead of time, run this in a separate job without much overhead. Pretty easy to get started is kind of the idea.
Cool. I can give a little bit of color as well on how MegaQC has evolved. So we're also looking to expand multi-QC's use and really kind of aggregate that work as well. So I know that we haven't had a bunch of time to work on MegaQC recently, but it's something that's going to be resurrected in the future as well. Cool. Round of applause for Edmund.